Hi everyone, thanks for coming for the new talk of the day. And Tom, I will invite you on stage. So today we have Tom from Nvidia, and we're gonna have a very interesting talk. Thanks for being with us today.
You're welcome. Happy to do it.
Thank you so much. We're gonna talk about many interesting things and the future of broadcast, including 2110, Gen AI, and more to come.
Yep, that's right.
So we work a lot with Nvidia, and we can come even closer in the lights.
Okay.
Please feel free to come here. And you're gonna present that. It's always a pleasure to collaborate together. And I think there's some example of how we work together in film and broadcast with Nvidia.
Yeah.
And you're gonna present that. So I'll leave you the stage, and I'll come back after.
Great.
All right, perfect.
Thank you. Hello. Yes, I'm Thomas True from Nvidia. I'm a senior applied engineer for professional video. So in that role, I work with great developer partners like Mo-Sys, and I help them integrate the GPU and networking technologies into their products. So yeah, today I'm going to talk a little bit how generative AI and SMPTE 2110 and the combination of those two emerging technologies are elevating virtual production, and more like virtual production of like live media, virtual sets and things like that. So let's start with the generative AI piece. So at NVIDIA, AI takes a lot of different forms. It's a combination of data science and recommender engines and computer vision and inferencing and then generative AI, which is the piece that we think about here, is just one piece of a bigger system. So it's much more than just the content creation piece. You can do audience analytics, and you can also get feedback of what your audience is watching, so that you can ultimately create personalized streams of that, so you can really more engage your audience. So we have at NVIDIA tools to do all these things in combination. In this industry, there's always a new trend, right? HD to UHD and et cetera. Well, now the trend is, how do we need to engage our audiences, because there are so many ways for them to receive content and view content. We need to engage with them to keep them added, or to keep them interested in the content, and not make them, for example, change the channel. So these take the form of hyper personalization, where we use all the AI that I talked about on the previous slide to create a personalized stream for them, so that what they see is tailored for their interest, right? And then we have intelligent agents, and then different ways of packaging the media, and finally streaming services to engage the audience. So another trend in the industry is software-defined workflows. So if we take the whole idea about adding AI into our workflow to produce streaming media for the hyper-personalization, well, we've kind of developed a platform for that, where we take common off-the-shelf hardware, we add like a virtualized stack on top of it with Kubernetes, and then on top of that we can put AI tools, and on top of that you put applications, and you build workflows to create great content with AI tools and all the other creative tools like those that you see around here on the show floor. And it's a software defined, so you don't get locked into one piece of hardware. It's all software. Yeah, so diving more into the AI piece. So there's three different kinds of AI, right? So there's the generative AI, which is taking content and using large language models or large vision models and creating new content from existing content. And then there's perceptive AI, that's looking at your audience data and the data that what your consumer is watching, right? And you can take the perceptive AI and feed it into the generative AI to make the custom streams. And then we also have what we call video AI, which is the AI that you've seen around here for a couple of years now, at least, where we use AI to clean up video or clean up audio. So this is the AI that does super resolution. So it takes HD content and creates UHD content, or it does noise removal on audio streams. And in broadcast and live media, it's super useful for things like contribution feeds into a virtual set, right? Someone's sending you some video from their cell phone, right? And you need to upres it to UHD to fit in your program feed, but also clean up the audio. So that's what we call video AI. So it's using some of the SDKs that we have at NVIDIA for doing video processing with AI. So generative AI, which is kind of what I came here to talk to today about, is it's kind of taking off right now, where we take large language models, large vision models, and we create new content from existing content and existing video, right? So we kind of call this the iPhone moment, because it's just taking off now, and the sky is the limit. And what you see here on the show floor today is just kind of the beginning of using AI to create new content for your viewers. And then if you're in a production studio or in a broadcast facility, there's steps to get, how do you get AI into your product and in front of your viewers, right? So it starts with, you have to acquire the data. Well, in Gen AI, maybe it's your content library, or maybe it's also content library combined with all your audience data. And then from there, you have to curate the data and organize it in a way that you can train your foundation model to the goal that you want to achieve, right? And then once you do that, you you train the model, and then you deploy it in inferencing. And this is a big lift for a lot of companies, right? So at NVIDIA, we're trying to make this easier by creating tools and SDKs and what we call NIMs, which are neural information inference microservices that do this heavy lifting for you. And I'll talk about a bit about more of that in the next couple slides. So yeah, so how do you start with AI? Well, you can from the NVIDIA website, you can download fully trained models and AI APIs and develop them into your application to return the AI, whatever you want to do with your AI, and create prototypes, or you can deploy with what we call NIMs, the neural inference microservices, which are, in NVIDIA, we've done the work for you. We take the foundation model, we train it on our data, or maybe you give us data. Then we deploy it, we put it in a Docker container, and we set it up so it can be deployed in a Kubernetes virtualized environment, either on your premises or in the cloud. And then your application can call into it, send queries, and get the AI back from it. So again, we call those NIMs. And as we go forward, you'll hear a lot more about NIMs, because AI can be hard, and we're trying to make it easier. So yeah, different software solutions that are available today. There's a lot of commercial AI software solutions. All you have to do is walk around here, and you have AI in all different applications to make the content creation process easier. But then also you can develop your own application using some of the tools that NVIDIA provides, SDKs, the NIMs that I talked about, and the foundation models that you can download from the NVIDIA AI website. Or you can be part of our Inception program. And we have an Inception program, and NVIDIA takes small startup companies and it helps them get off the ground with their idea. It gives them access to tools that maybe not public tools, that help them in lower cost hardware and GPUs and time on different GPU clouds, so they can train their models. And that's what we call the NVIDIA Inception program. And one of the examples of that is a company called Kubrick, which makes the background plates from AI. So you can give them a sketch, or you can give them a photo, and automatically creates your background plate, and it creates the different elements and the different layers. So it's like it becomes 2.5D, and then you can import that into Unreal Engine or into one of the other engines used for virtual production, and then you quickly have a background plate. So this is one example of that you can use in your virtual set. So this is one example of generative AI being used in virtual production. And then like another example would be MoViewer from Mo-Sys, right? Where they generate the alternate camera views that the producer sees from the single camera view that is actually live, right? So that's another generative AI example. And if I were to look into the crystal ball in the future, I mean, if you look at a lot of AI research, there's a lot of AI research right now around neural radiance fields, which are also called nerves, which right now they're doing a lot of 3D image reconstruction with static images, right? But just around the corner, we're going to have the GPU power and the algorithms to be able to do 3D reconstruction from multiple cameras in real time. So your virtual production set in the future is going to be 3D generated in real time from multiple camera views. So you have true 3D depth and AR objects all working together. And then there's Gaussian splats, which is a related kind of technology. Again, today it's research, but around the corner, it's going to be real, and we're going to be seeing it here at IBC in the Mo-Sys booth. So yeah, so that's AI. That's one of the big technologies that's going to bring virtual production to the next level. And then the next is moving to SMPTE 2110 video over IP. And so we've kind of moved from AI to the video side of it. So yeah, so in a traditional virtual production set, you have a bunch of disparate technologies. So you have cameras that, okay, maybe they're SDI moving into CCUs, and then you have an LED wall that's driven by DisplayPort or DVI or HDMI cables, and you have networking, and you have video, and you have like kind of then you have a good old analog black burst signal generator syncing the whole thing. So and it's a bunch of disparate pieces that they kind of work together, but they don't. The problem is they don't scale. So, like if you're using Unreal Engine, for example, in this case, they're generating the interfrustrum view on every one of the render nodes. So they're duplicating all that work and requiring 2 GPUs per render node because they need one for the inner frustrum and one for the outer frustrum and the compositing and all that. So to make that easier, we worked with Unreal and we integrated SMPTE 2110 into Unreal Engine through plugins. So what that does is it gets rid of all the disparate cables. Now everything's networked. So you have a network switch, your cameras do 2110 networking into the switch, and then your wall controller, it takes 2110, like the Helios wall controller from Megapixel. So, and then you have PTP for synchronization. So it's all networking now. There's no other cables. And the big advantage is it scales. I won't say it's simpler because moving from something we trust like SDI and HDMI and DisplayPort to now video over IP networking, it's not always simpler. So, but the great thing is it scales and it's way more flexible. It's easier to support crazy video resolutions, which in crazy timing, that's what we do in virtual production, sending 3 times the frame rate and half the resolution and all that kind of stuff. So that's the great benefit of a SMPTE 2110 infrastructure. And then it also gets simpler because we got rid of the CCUs now. So now, because we can take the inner frustrum and render it once and then multicast it over the network to all the render nodes, we're only rendering the infrastructure once. All the render nodes all have a single GPU. It's not good for Nvidia because now we only sell 1 GPU instead of 2, but we hope that you'll have more nodes to have where you used to only be able to do 2 cameras. Now you can much more easier add 3, 4 cameras and still have the performance that you need. So how do we make this happen with some of the Nvidia tech? So the first thing we do is we use a high-speed networking card, and we call this a DPU, and it's a ConnectX NIC network interface card with ARM cores on it. And why do we need the ARM cores? Well, we need the ARM cores to do PTP synchronization because on Windows you don't have good PTP. So one big piece of the puzzle is the DPU, and we call these the Bluefield DPUs. And then the next part is the sync card. So you have an LED wall, you need to sync all the tiles on your LED wall to the cameras. And how do you do that? Well, we use it with what we call the quadro sync. And this is not something that's new. We've been doing this for many years, but we've been doing it, syncing it to a traditional broadcast blast burst signal. Now we can drive it with PTP derived from the DPU, and that's what we do. So yeah, so this is kind of shows how we do it. So we need to synchronize all the displays with the camera. So we have, and then the wall controllers. So everything is running on PTP. So precision time protocol that's generated by the Grandmaster PTP clock that's synced to the satellite GSM time. So all the machines, all the systems have the same PTP time. So what we can do is we can extract we have technology in the DPU to extract the frame sync. There's a frame marker in every packet or every frame of the 2110. We can extract the frame sync. From that frame time, we can go all the way back to the epoch and we can tell exactly what frame we're on. And we use that frame sync to drive the quadro sync, which then drives the GPUs, and everything's in sync. So just to wrap up, two new technologies that are really enabling and letting us take virtual production to the next level are generative AI, which is going to make it easier and quicker to generate content that's more engaging for your audience, and content that's more personalized for your audience. And then to be able to use SMPTE 2110 video over IP networking to get rid of all the disparate cabling and craziness that you have in your virtual production environment, and let you scale to have more cameras, more render nodes, more resolutions, and be able to do higher resolutions and higher frame rates. And all that comes together with partners like Mo-Sys doing virtual production. So that's my talk today, and thanks for listening.